Okay, this is another chapter, more particularly in the 402. So 402 means it's a natural product chemistry. So under that, the unit 3, okay. Uh, is it unit 3 or unit 4? So let us confirm later. But the chapter name is insect pheromones, and one more part is there, that is prostaglandin. In the insect pheromones, we are going to discuss about the synthesis of pheromones. Okay, more particularly, there are seven pheromones synthesis we are going to discuss, and here the synthesis means one is normal synthesis, another one will be the stereochemical stereospecific synthesis. So two synthesis we are discussing for every pheromone. Let's give an entry. Okay, right. So, insect pheromones means more particularly the synthesis part we are discussing. Uh, uh, Synthesis means a common synthesis, and other one will be the stereospecific synthesis. So, two methods of preparation of pheromones for each pheromone we are discussing. So there are totally seven pheromones as per the syllabus. So this will be the information about pheromones. So sometimes they will ask what is pheromone and how it is useful in pest control. Okay. Otherwise, how the pheromones are useful in pest control. I think you are aware about pest. So pest means any is any organism which causes damage. Okay. uh, Such species are called pest. So pest may be a organism or a species or animal if it is causes a damage to the other species or food products. It's called crops, crop protection, food protection, plant protection. Okay. So let's look into the insect pheromones. So pheromones are the substances which are secreted to the outside and which when passed on the another individual of the species cause it to respond in a particular manner. So these are thus concerned with the coordination of individual of the same species. So these are often important in sexual behavior and in regulating the social insects. So defensive secretions, on the other hand, they are deterrents against potential predators and parasites. So these are also called as hormones. So hormones, okay, let's give an entry. Right, hormones. Hormones meaning chemicals. So which are adaptatively favorable to the producer, and these are usually in large quantities than pheromones. So pheromones first identified in 1959 by Buten Dent is the name of the scientist. So pheromonal communication is ubiquitous in insects, right? And in most insects, pheromones are produced by glandular epidermal cells. So this is a subheading. What is that? Pest control using pheromones. So pheromones has been used in major ways in crop protection. Crop means whatever the food grains obtained from the agricultural source. So control by monitor. So these are the steps: control by monitor, control by trapping, control by mass trapping. So these are the three steps to protect the crop by using to protect the crop and to destroy the pest using pheromones. Again here, the pheromones are used as a bites. Okay, it traps to capture the insects of the opposite sex and form the basis of monitoring a pest population. So this is controlled by monitoring and controlled by trapping. So trapping is employed to concentrate pest insect. So concentrate pest insect into the restricted space to kill the pest easily and cheaply. So same thing, if this is done in mass, means large quantity, then it's called control by mass trapping. So mass trapping is employed to concentrate the pest insects into restricted space to kill the pest easily and cheaply. And these pheromones are classified so based on circumstances. So here there are four types of pheromones. So one is sex pheromones. This is for attraction, and aggregating pheromones to gather food, and alarm pheromone, and this is nothing but a dangerous conditions, and a trial making pheromone to follow a track. And this will be the Greek word bite, that is nothing but a that will be nothing but a pheromone. So this is about a introduction about insect pheromone. So now I'm going for a particular pheromone and what is the name of the pheromone and where it is isolated and the structure and then synthesis. So more particularly two or three methods of synthesis. Out of three or out of two, one will be the stereospecific synthesis. So again, I'm taking the plus Disparlure. Okay, this is Gypsy moth sex pheromone, and it is a sex pheromone secreted by female moth, and this will be the structure. So what you can observe here, so there are 7 carbon atoms here and there are 10 carbon atoms here, and this will be the epoxide. So what you need to remember here, so just remember the epoxide. So in the left hand side there are 7 carbon atom, right hand side 10 carbon atom. So totally 18 carbon atoms that you need to remember. So then uh, uh, so if you want to numbering, you have to start with this now carbon. This will be the 1, this will be the 2, this will be the 3, this will be the 4, this will be the 5, this will be the 6, and this carbon is called 7, this carbon is called 8. So here 10 is there. This carbon will be the 18. So 7 comma 8, and this epoxide is in the cis form. So that is the reason it's called Z. Z 7 comma 8 epoxy 2 methyl. So this substituent, this is the substituent 2 methyl octadecane. So decane means 10, octa means 18, octadecane means 18 carbon 1. So let's look into the first method of synthesis of Disparlure, more particularly plus. So plus means dextrorotatory one. So this will be the starting material. So what is the name of this compound? This is 1, 2, 3, 4. Okay, maybe uh, since it is a four carbon atom one, so you can say that isobutyl. Okay, isobutyl magnesium bromide. Isobutyl magnesium bromide uh, Isobutyl magnesium bromide, when it is treated with oxetane, this is a four-membered ring with oxygen, oxetane. So what is happening here? There will be a new bond formation between this carbon as well as this carbon. So once there is a new bond formation between this carbon and this carbon, so this carbon becomes a 6 carbon atom moiety. So 1, 2, 3, 4, 5, 6, 7, 7 carbon atom. And of course, if we are considering substituent also, it will be a 8 carbon atom. So but overall, what you need to remember? So you need to remember there will be a new bond formation between this carbon and this carbon. Okay, so that is how this product is obtained. And when it is treated with HBr, so what is HBr? HBr is a brominating agent. So what it will do? It will brominate the hydroxy. Hydroxy is converted into uh, bromide. So there will be a removal of water. So this here I mentioned the removal of HBr, that you need to change it to H2O. So once there is a bromide is obtained, so it was converted into triphenyl phosphine bromide. So when it is treated with the triphenyl phosphine, this is the method of conversion of bromide to the triphenyl phosphine bromide. What it means? It means that you are converting a halo alkane to halide. Now this is a halide. So what it will do? It will form a double bond with the carbonyl carbon. So this reaction is called Wittig reaction. So Wittig means if we are treating with a halide, halide means that may be a phosphorus halide or maybe a sulfurous halide. So if halide is treated with carbonyl compound, you will end up with the alkene. So what is the living group here? The living group here is triphenyl phosphine oxide. This triphenyl phosphine oxide, it will take this oxygen and go out. Then potassium, it's a facilitator. This reaction proceeds catalyzed by potassium. What is HMPA? Hexamethylene phosphoric acid. This is a solvent. Okay, this is a solvent, and potassium is a facilitator, and this reaction proceeds. And name of this reaction is called Wittig reaction. So once there is a double bond formation like this, once there is a double bond formation, it was converted into uh, epoxide, which is nothing but a oxidation by using a per acid. So what is the name of the per acid? Metachloroperbenzoic acid. The obtained compound is Disparlure, and this will be the what is called as a IUPAC nomenclature. So this is about the first method of synthesis of Disparlure. Okay, I think clear, no? So first step is the Grignard reaction, treating. Then how you can get this oxetane? I think you are aware about the 2+2 cycloaddition. So take aldehyde, more particularly formaldehyde. So formaldehyde and ethene. So ethene and formaldehyde, when it is reacts in presence of light, gives oxetane. So this oxetane subjected to Grignard reagent, you will get an alcohol. Alcohol and bromination get a bromide. Bromide and treating with triphenyl phosphine, you will get a halide. This halide is treated with a long chain aldehyde, so giving rise to alkene. This alkene subjected to oxidation with perchlorobenzoic acid, you will get Disparlure. This is about the one method of preparation of Disparlure. And the second one, it's a method two synthesis of Disparlure. So here what I am taking, octadiene, cyclooctadiene. Name of this compound is called cyclooctadiene. So this cyclooctadiene, when it is subjected to ozonolysis, So ozonolysis means convert one of the double bond to aldehyde, and then that aldehyde, when it is treated with the Jones reagent. So Jones reagent, I think you are aware about Jones reagent, Fourier reagent, okay, ozonolysis. These are all comes under oxidation. So you learned in your previous experiment, previous semester. So ozonolysis only cleaves this particular double bond. Okay. So ozonolysis cleaves only this particular double bond into aldehyde here. So that dialdehyde converts into acid when it is treated with the Jones reagent. Once the Jones reagent converts the aldehyde into acid, then what it will do? Methanol. Okay, methanol means esterification. So obtained acids are subjected to esterification. Here I am not mentioned about esterification. You convert this acid into ester. Okay, and then this is Kolbe reaction. So what is the role of Kolbe reaction? So Kolbe, when it is subjected to Kolbe reaction, this carboxylic acid and this carboxylic acid both will go out as a decarboxylated product. Then there will be a new bond formation between this carbon and this carbon. Okay, what it means? There will be a loss of two carbon carboxylic acid, and there will be a new bond formation between this carbon and this carbon. So this follows a electrolysis method. So what is electrolysis method? Electrolysis method involves a free radical reaction. So where there is an involvement of free radical reaction, where there is a decarboxylation, where there is a new bond formation between this carbon and this carbon. So that is how a compound is obtained. So look here, what I mentioned. This is this colored carboxylic acid. This colored carboxylic acid is going out. There will be a new bond formation between this carbon and this carbon, and double bond is this. After the double bond, three carbon atoms. That is this. And this again, this compound as well as isobutyric acid is subjected to Kolbe's reaction. So again here also Kolbe's reaction, what is happening? There will be a electrolysis. Electrolysis means removal of carbon dioxide 2 molecule, and there will be a new bond formation between this carbon and this carbon. So that is how a alkene is obtained. This alkene on treating with uh, metachloroperbenzoic acid. It is a peroxide oxidation. Epoxide is the product. Okay, so this is about second method of preparation or synthesis of plus Disparlure. So next I am talking about the stereoselective synthesis or preparation of Disparlure. So first you should know what is the stereochemistry of Disparlure. The stereochemistry of Disparlure is this one. So look here, the epoxide, this is called cis epoxide, and here 10 carbon atoms, and this will be the sixth carbon atom. So this will be the structure of stereochemical Disparlure. Okay. So this will be the stereochemical structure of Disparlure. So then what is that? I think you have to start numbering from this carbon atom. This is 1, 2, 3, 4, 5, 6, 7. So this seventh carbon one is having R configuration. 8 carbon will have a S configuration. So 7R, 8s epoxy 2-methyl. So this one 2-methyl octadecade. This is the stereochemical structure of Disparlure. So how one can prepare this stereochemical one, starting with a amino acid. So what is the name of this amino acid? I think you are aware about the glutaric acid. So the name of this amino acid is called glutaric acid. So when this glutaric acid is treated with nitric acid, so what it's not a nitric acid, it's a nitrous acid. So what it will do, it will convert a amino into diazonium salts. Once there is a formation of diazonium salt, N2 will go out. Then what will happen? There will be a new bond formation between this carbon and this carboxylic acid. No. What will happen? The lone pair present on this oxygen will attack this carbon and the N2 will go out. So I will repeat again. So glutaric acid, when it is treated with nitrous acid, so it will convert NH2 into N2Cl. So at that time, the lone pair present on this alcohol means acid will attack this carbon, N2Cl will go out. So that is how lactone is obtained. Once there is a lactone is obtained, of course, here there will be a carboxylic acid. That means this carboxylic acid. This carboxylic acid was treated with phosgene. So what is phosgene? COCl2 is the phosgene. What its role? Its role is a chlorinating agent. And what it will do? It will convert this acid, carboxylic acid, into acid chloride. So once this acid chloride is obtained, it was treated with a Gilman reagent. So this is not Gilman reagent, it's a cadmium compound. So this alkyl cadmium will also act as a source of alkyl group. So what it will do, it will transfer this alkyl group, 10 carbon atom alkyl group, to this carbon, and Cl will go out. So there will be a compound formation like this. Once this compound is obtained, so it was treated with sodium borohydride. You know that sodium borohydride act as a source of H minus. That H minus can attack from the opposite direction, as well as the means rephase or C phase of this carbonyl group. That leads to a two compounds, two isomers. I think this is what is called as a prochiral carbon. So that leads to a two isomers or enantiomers. Enantiomeric mixture is possible, and that can be separated. After the separation, it was treated with pyrenene. So pyrenene is a, and you know that after the reduction, ketone will be converted into alcohol. That alcohol is protected by using a pyrenene. So it's called THP, tetrahydropyran. Tetrahydropyran is a protecting group. So that is how this protected compound, hydroxy protected lactone, is obtained. This compound is called lactone. Lactone means cyclic ester is called lactone. Then what will happen? Okay, so this in presence of H plus. So in presence of H plus, what it will do? It will uh, cleave. How it will cleave? So more particularly, there will be a cleavage. The lone pair present on the oxygen can picks up this proton, and OH minus can attack this carbonyl carbon. So that is how hydroxycarboxylic acid is obtained. So once there is a hydroxycarboxylic acid, is it a carboxylic acid? It's a carboxaldehyde. Means aldehyde is obtained. Hydroxyaldehyde is obtained. Afterwards, what will happen? So this was treated with ylide. Ylide means replaces this oxygen, forming a double bond like this. And this double bond is reduced to single bond when it is subjected to catalytic hydrogenation, that is hydrogen in presence of uh, catalyst, platinum catalyst. This product is obtained. So now, and after the reduction of after the conversion of double bond to single bond, it was treated with tosyl chloride. So tosyl chloride, what it will do, it will convert a hydroxy, here hydroxy is there, no, it will convert hydroxy into tosylate. This is called tosylate. Why we are converting? Because hydroxy is a poor living group, whereas the tosylate is a better living group. Why? Because in this, when we are treated with acetic acid, the deproduction of tetrahydrofuran is happening, tetrahydropyran is happening, hydroxy group is obtained. That hydroxy group, lone pair present on this oxygen, will attack this carbon and tosylate is going, and that is how epoxide is obtained, and this is the structure of Disparlure. More particularly, this is about what is called as stereospecific synthesis of Disparlure. Is it okay? Any doubt? So up to this. So, and one more thing, you should the 404 and 403. You should write the internal test. It will be a 40 marks one. You should, all of you should come out with one particular date, and you should tell me in the next week you are going. If you are willing to write online, you can write. If you are willing to write offline, offline may be the better one for your uh, uh, for the interest of you. Offline may be the better one. You should write 404 and 403 also, because maybe in a few hours, maybe after the completion of this insect pheromone and prostaglandin, one more also you need to write, that is 4021. So this is about the thing. Maybe uh, all of you should prepare for the 404 and 403 test. 40 marks question 1, and maybe you can write 1 in the next week. Otherwise, if you want to write 2 in the next week, that's also fine. That's what I would like to